Okay, here's the second part. We're going to now do taking the square root of both sides for these next two. And just like you would think, you're just going to square root, square root. So when I square root both sides, though, you have to be careful that you do indeed get the plus or minus, and this would give me root 3 over 2. Well, that works out pretty nicely because I do now just have one of my basic equations. And so in this case, though, it is plus or minus, so I'm going to be able to have lots of different solutions, right? I'm going to have pi over 3. We're in radians here, right? I'm going to have 2 pi over 3 because those are the positives, but then these are the negatives down here, so I'm also going to get 4 pi over 3 and 5 pi over 3 down here, right? So I'm going to have all of these. There's a couple ways you can write this, right? So I could just write for all of them separately. Pi over 3 plus 2 pi k. 2 pi over 3 plus 2 pi k. 4 pi over 3 plus 2 pi k. And 5 pi over 3 plus 2 pi k. That's a fine solution. It's correct. There's nothing wrong with it. But if we want to condense, and again, I talked about this on Friday, when you want to condense, notice that this pi over 3 and this 4 pi over 3 are exactly pi away from each other, right? And again, on this side, it's pi away from each other. So if I want, it might be easier to condense these two together into just saying pi over 3 plus pi k. And I can do the same thing for the 2 pi over 3 and the 5 pi over 3, since they're exactly 180 degrees away from each other. I can just condense those two into 2 pi over 3 plus pi k. Again, where k is an integer. Same idea with all of these. All solutions in degrees. Square root, square root. Don't forget the plus or minus. When is cosine equal to positive or negative 1? Well, it's equal to positive 1 over here, negative 1 over here. So for that first solution, it would be 0 plus 2 pi k. Oh, degrees, sorry. Change that. Plus 180k. And this one would be 180 plus 180k. Now notice again, in this situation, these are exactly 180 degrees away from each other, so we can just condense that. Oh, I already wrote the right answer. Oh, sorry. Into 180k. Sorry, this should have been 360s. I'm going to go back. See, this is why I'm going home today, guys, because I feel sick and I'm not on my game. All right, there we go. You would have all gotten candy for that one. Okay, so the original answers would have been 0 plus 360 or 180 plus 360k, but then I can condense them just into the 0 plus 180, which would just be 180k. Again, where k is an integer. Okay, turn the page. Again, square root, and work it out. This one, it's just the interval from 0 to 360. So I get tangent of x equals plus or minus 1. So when are the 4 places where tangent is equal to positive or negative 1? And it would be all of my 45s, right? So I'd be at 45, 135, 225, and 315. Nice and easy because you've got all the positives and negatives, right? All 4 of these places. Okay, square root of 1/2 plus or minus root 2 over 2, right? Once I rationalize that, because I'll get 1 over root 2 and rationalize. So I'll get plus or minus root 2 over 2. Again, those are my pi over 4s in this case, and I only want from 0 to 2 pi. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Nice and easy. Last part. This is the opposite. When you have an equation that has a square root in it, we're going to square both sides, but remember, anytime that we square both sides of an equation, we could have extraneous. And so you do have to go back and check these. Okay, so when I square the left and square the right, I end up getting sine of x minus 1/2 equals 0, so I have that the sine of x equals 1/2. All solutions in radians, we have seen this a few times right now. sine is equal to 1/2 at pi over 6, plus 2 pi k because it's all, and 5 pi over 6, where sine is positive, where k is an integer. All right, how about this one? Square both sides. Oh wait, I gotta go back. I gotta check. Okay, so we're supposed to check these answers, right, to make sure they're not extraneous. So all that I want to do is take that pi over 6 and plug it back in, and take the 5 pi over 6 and plug it back in, right? So if I take pi over 6, I'd have sine of pi over 6, which is 1/2. 1/2 minus 1/2 is 0, and sure enough, we're fine. 5 pi over 6, same thing. I'll get 1/2 minus 1/2, which is 0. So those both work fine. All right, let's see what we have here. All right, so now I'm going to have to move stuff around, and this is going to become a factoring problem. Cosine squared x minus cosine x minus 2, and that factors into cosine x minus 2 cosine x plus 1. So I have two solutions. When is cosine x equal to 2, and when is cosine of x equal to -1? Obviously this is never, but cosine is equal to -1. We're looking for degrees here at 180 degrees. We want all solutions plus 360k. But I have to always check my answers. So I take this 180 and I plug it back into both sides. So when I plug that back in, I'll have the square root of cosine of 180 on the left. But wait, what's the cosine of 180? It's -1. So I have the square root of a negative number, and this is automatically no solution because that was extraneous. Okay, so that one didn't work. Overall, there is no solution to this problem. Right? So when you're checking it, that's what you're going to see. You're going to get the square root of a negative. You're going to get a non-real solution. Okay, last two. Same idea here. On this first one, in order to square both sides, I have to move some stuff around first. So I'm going to move this to the other side. So I'll have root 3 times the sine of x equals the square root of 1 plus sine squared x. Now I can square both sides. So then I'll have 3 times sine squared x, because that'll get the square, right? This will cancel 1 plus sine squared x. Let's move stuff around. So I'll have 2 sine squared x equals 1. So I'll have sine squared x equals 1/2. And I take the square root, and I end up with sine of x equals plus or minus root 2 over 2 after I rationalize. All right, we're in the interval from 0 to 360, so when do I get root 2's over 2's? Those are my 45's. All of them, because it's plus or minus. And I want to check these, right? So basically, plugging them back in here isn't going to make much difference, but when I plug them back in here, this is where I could have a problem, but since I'm squaring it both times, I'm never going to get a negative, right? So I would have root 2 over 2 squared, which would work fine. And then I'd have negative root 2 over 2 over here for these ones, right? And negative root 2 over 2, because I'm squaring it, should work out just fine. So these 4 will all work. You're going to have your calculators as well, and so you can obviously just take each one of these, store it in your calculator, and type in that entire expression just to make sure that it does indeed equal 0. Okay? So use the store button to check your answers. All right, last one. Let's square both sides. And I get 1 minus cosine x equals 0, or 1 equals cosine x. So when is cosine equal to 1? And we're just going from 0 to 2 pi. And so cosine is equal to 1 right there. So my answer would just be 0. Plug it back in to make sure it works. 1 minus cosine of 0, which would just be 1. So 1 minus 1 would be 0, square root, and we're good to go. Okay? I'd like you guys to work now in your practice packets on page 17, and then you can either start your homework, which is 9-4-2, or you can keep working in the practice packet on pages 18 through 20, and you can do your homework tonight on 9-4-2. Tomorrow in class, I'll answer all your homework questions, 9-4-1 and 9-4-2, and we'll continue working in your practice packet to practice this. Quiz on Wednesday, just on 9-4. And then Wednesday is also part 1 of your final on the graphing part. So make sure you're doing that graphing worksheet. The last thing is that your kit is going to be due this week on Friday because we all switched teachers next week and Mrs. Weber told her class it was due, so we're going to make it due. It's nice and easy. You can work on it right now and probably finish in 5 minutes. So you can turn those in to Mrs. Weigel at the end. Okay? All right. Thanks, guys. Email me if you have questions. I'll hopefully see you tomorrow.